Hello, welcome to Ludic Science. In this video I will show you how to make this little device. It is a tangent galvanometer. It is one of the first instruments that were made to measure small currents. As you can see, it is very simple. It only uses a coil of magnet wire and a compass. In the video I will show you the details of how to make it and to test how it works. The coil must be made with many turns of very fine magnet wire. I'm going to use wire gauge 34, which is the finer that I have at hand, and I'm going to wind it over this plastic cap, which has a diameter slightly larger than that of the compass. Next time you need a PCB for your electronics project, consider using the professional services of LCPCB. LCPCB is the world leader in PCB fabrication. You can order online. You just need to register, upload your Gerber file, and wait a few days for your PCBs at an unbeatable price. This is the finished coil. It has only 150 turns. For more sensitivity, you will need to give many more turns and finer wire. However, for demonstration purposes, it will be fine. The base is the same plastic cap that I used to wind the coil. There are a couple of grooves at the sides where the coil is inserted, and it is glued with epoxy glue. And here we have the two wires of the coil that will be connected to the current that we want to measure. And our compass goes here. How it works? Well, when we apply a current to the coil, a magnetic field is generated that is perpendicular to the coil. Therefore, the needle of the compass will try to align with that magnetic field. Let's see, I'm going to use this battery to apply a current in the coil. Okay, and you can see how the needle of the compass is aligned so that it is perpendicular to the plane of the coil. Notice that there are two magnetic fields at play here. One is the magnetic field of the Earth, which tries to align the needle of the compass to the north, like we have now, and the other is the magnetic field of the current that we want to measure that tries to move the needle into a position that is perpendicular to the coil, if the current is strong enough. Therefore, in order to use the instrument, we need to move the base until the plane of the coil is pointing in the same direction as that of the needle of the compass. That is the zero value, zero current, or needle pointing to the north. Now, when we apply a current to the coil, the needle will try to move in a direction that is perpendicular to the coil, if the current is strong enough. A small current will only deflect the needle a little bit, and that is an indication of how strong the current through the coil is. Okay, so let's do the test. I have connected the instrument to the power supply. I added a 100 ohm resistor in series because otherwise we will need to use very small voltages. And with the multimeter we will be monitoring the current. The plane of the coil is parallel to the needle of the compass, and the tip of the needle is pointing to the zero of the scale. I'm going to turn on the power supply and start raising the voltage. First I will apply 0.1 volts. Observe the needle. It moves around 2 divisions in the small scale, and we have less than 1 milliamp. Now let me put 0.2 volts. Current increases and also the deflection of the needle. Now 0.3, 0.4, 0.5 volts. The needle continues to deflect. We now have 4 milliamps, and let's continue to increase 0.6, 7, 8, 9, 1 volt. We now have around 8 milliamps, and the needle has moved more. Of course, the sensitivity is greater at the first points in the scale when the angle of deflection is small. Now let's move to 1.5 volts. The needle moves a little bit more, and the current is almost 12 milliamps. 2 volts. The needle moves very little now. We need to increase the current a lot for a small deflection of the needle. And that indicates one of the problems with this instrument. It is sensitive at the beginning of the scale and loses sensitivity at larger currents. I'm going to return to 0 voltage. The current decreases and the needle returns to the 0 position. Well, as you could see, our little instrument does work. That is, you can measure the current. In order to use it in a practical situation, you need to calibrate it first. That is, you need to measure the current and the deflection of the needle, as we did before, and for each value of current, annotate the deflection of the needle and make a special scale that shows the current corresponding to each angle of the needle. It is a very simple instrument, very easy to make, but of course simplicity has a cost, and the cost is that it is not very precise, and also the sensitivity depends on the current. Small values of current, the instrument is more sensitive and loses sensitivity as the current increases. Well, that's all for today. I hope you liked this little experiment. Thanks for your visit and see you in the next video.